So what is the solution for this issue? There are a couple of solutions, but one of the most common one is transactional outbox pattern. And apart from that, we have things like change data capturing, distributed transaction, and so on. So in this video, we are going to focus on the transactional outbox pattern. The idea is we will only write to the database, and then a separate process will handle the change accordingly. So in order to do this, here we have this order microservice, same as before. This time, if you notice here, as previously, we are creating a sample order and we start the database transaction. Within the transaction, you notice that we first insert to the orders table. So within this second, right, we insert it to another table called outbox. So here it's kind of it's sort of it capture all the things that happen to our data in our database, business data. So order is something related to business data. Outbox is kind of storing certain events and things that happen based on the changes to the our business data. So here in the first write, we write to the business data, and then we emit and we record an event in the outbox table in the same database. So that means we can utilize the database transaction features. Now if you are using transaction, if either one is failing, the database will automatically roll back it and make an error. So there will be no partial data written into the database. So basically we are doing a atomic write here, and then that's it. So we commit it and we exit. That's it, nothing else here. And same as before, the shipping microservice is similar as before. It is just creating a Kafka consumer and just consume all the messages from that subscribe topic. That's it. Consume, and it will just write to the shipment database. Right. So this is the idea, but in between there we have a relay. I will explain what is this relay. Now in this new solution, what will happen is instead of emitting this, we will not do this. We will not call Kafka from the order microservice. Instead, we will save order here. During this save, we will do two things. One is create row in order DB plus create row in outbox table, order table, table, and create row in order outbox table as well. Now this is within a transaction, database transaction. So if one is failing, the entire transaction will fail and roll back. So we don't have to worry about partial data or stale data. So this is what we will do here. We will save and we will exit. That's it. You can see there's no connection between order microservice and Kafka. So instead, we will have a separate process called relay. For each microservices, we will have one relay. This relay, I will call it relay 1. The relay 1 will consume data from the order database from here to here, and then it will read all the items from outbox table. It will just read from outbox table, and then it will create or emit events to the Kafka. And now we can see relay is the one who will emit event to the Kafka. And as before, shipping microservice won't know about any things that go in beyond the Kafka. It will just consume event from Kafka, and it will do the same things as usual as before. Right. So this is the proposed solution. Now let me show you what the relay looks like. So this is the relay. We need a PostgreSQL connection and Kafka producer, because relay is the one that will produce events to the Kafka. And then here we are using just advisory logs to prevent multiple relays from publishing same event again and again. And then we go here inside the publish until log lost. What we will do, we will read from database and we will publish to the Kafka. That's it, right? So we read events that are not published yet. Here the publish at is null. We will read, and then we will process them, and we will produce events to the Kafka, and then we will update the publish at, right? So this is what we have right now. So let's go here and shut down all the previous servers, and I'm going to reset the database and everything, and we need to start this. So to start all the services, I have run outbox order, outbox relay, and Outbox shipping. So, but before that, we need to migrate our databases. So order schemas, we currently have only the order table. We also need a Outbox table. So I'm going to create this in the order database. So let's create it, and we have created another table here, Outbox. And the next thing is in the shipping schema also, I need another uh, table. Here I will just record the events that I have processed. I will explain why we need to do this. Right, so database ready. So I can just start the servers, Outbox order, and we will need so I'm not going to run shipment yet. I'll just run the Outbox order service only. Right, so now if you go back to here, just to confirm you, there is no order in the order database, and also we do not have data in the Outbox table as well. So let me just create a new order. I'm going to send it. Now you can see one order is created. We go to the orders table, we have that order, as well as in Outbox table we have one record which has the event ID, event type, and some aggregate ID and the payload. So payload contain all the data of the order, right? And yeah, created that, and it is not yet published. Now what will happen if I start shipment, make Outbox shipment, shipping microservice. We go to the shipping database and query this shipment table. You can see nothing is here yet. That's because in this Outbox pattern, there's we need a separate service to publish events, so which is this relay. Relay is necessary. So let me restart start the relay. Make Outbox relay. So now the relay is started. It will start to poll every 500 millisecond, and it got acquire the lock, and it publish one event in the table. So if I go to the here, this time you can see if I check here, the publish at happened. So this is already published. So if I go to here and refresh, so this is the event published into the Kafka. You can see it is published only one time, right? Now, from the shipment side, I also have this other table called processed events. Let me query this table as well. You can see we have processed this event that end with E0C, which is the event in our Outbox table from the order database. E0C, the same thing here, E0C. So why now you should understand how it works. And but one more important thing, why we need process events in shipment database, or other word, why we need a process event in consumer side. The reason is we are never guaranteed that a event will send only exactly one time. It could be sent multiple times. The reason is if I go to the relay, in here in the relay publish batch itself is a dual write problem. It has a dual write problem because here we first publish to Kafka and then we write to database. So what will happen if during here it fails? So this could fail around here, right? Otherwise it could return, like the produce sync could return an error. That doesn't mean that event is not like it could be in Kafka, it could not, we don't know. So if that happen, it will return early from here. In such case, this will never update. So in the next loop, in here in the next loop, when it select, it will again select that same event because the publish at is still null, right? So an event can be published more than one time. This is why on the consumer side, we need to maintain a processed event table. We insert it to the process event. If it is succeeded only, we will process. Otherwise, if the rows affected is 0, that means event is already in the process event. That means it is probably processed previously. We will just exit. Otherwise, we will just claim it and just process with our business flow. So this is why we need the process event on the consumer side. So I hope you understand. You can find this code in my GitHub profile as well. So just go through it, try to understand. Yeah, so that's the solution. And sometimes you do not have to implement this relay by yourself. You can use tool like Debazium. which is if you want for this case, you can set up this and you can connect it to your database tables, and it will automatically publish to Kafka. It's very powerful, very fast. You do not have to manage your own. This is how you can tackle the dual write issue.